Hi everyone, so today we're going to be doing Chapter 2, Section 1, Properties of Matter. So properties can be described as either extensive or intensive. Extensive properties depend on the amount of matter in the sample. So for example, if you were to worry about the mass of an object, you would take an extensive property measurement. So the mass is the amount of matter within that object. So a basketball here on the right is going to have a larger mass than that of the golf ball on the left. Volume is another example of an extensive property. So the volume of an object is how much space it occupies. So usually you think of these as fluid ounces, or if you're me, you think of them as tall, grande, and venti from Starbucks. But all of those are volumes of how much space that object occupies. Intensive properties, on the other hand, are going to be those ideas that are within that object. That's why there's the inside. So whenever you're looking at a basketball, think of there are all different types of basketball. I don't know how many of you play, but you can get something that is leather, which is great, which is usually what you see in the NBA, or rubber, which is great for on the playground, so you probably had those as little kids, or some type of synthetic composite. Those are all intensive properties that depend on the type of matter in that sample, not how much it is, not how much of it there is. So the absorbency of those basketballs we were just talking about. Leather absorbs a lot of water, so you wouldn't want to have a leather basketball for an outdoor event, whereas a rubber basketball, the water will slide right off. That's why you have, say, rubber soles on your shoes rather than just a cloth. Another one has, there are tons of other intensive properties. So if you look at the objects here on the right, you see a soda can and a watering pot. Take a minute to think of some of the intensive properties or things that you observe about those different chemicals that are right there. So some of them you may see are color or how easy it is to squish something. All of those are intensive properties. So whenever you are trying to identify a substance, you want to think of the composition in that substance. So, for example, aluminum is what makes up that can that we just saw, whereas copper is what makes up the watering can. And those are both examples of substances, and they happen to be pure substances. So they're all of the same atoms. So hardness, so an aluminum can is a lot less hard than that of the watering can because you can squish it with your foot. Color, conductivity, or how well it allows electricity to go through it. Malleability, that's the ability to squish or roll it out in a really thin piece. All of those are examples of those physical properties. So physical property is a quality or condition that can be observed or measured without changing the substance's composition. So you may think of those as transferring between a solid, a liquid, and a gas. And those physical properties are going to allow you to help identify the substance that you're looking at. So for example, some of these physical properties are shown here, where aluminum is very reflective. It's going to be used in a lot of paint, like that you may see on cars and things of that nature, whereas copper, it's not exactly perfect for seeing a reflection. Think of a penny in that regard. It can also scratch aluminum, but the opposite is not the case. Aluminum, it's pretty easy to bend and squish, whereas copper, you can scratch aluminum with it since it's so much harder. Copper is going to be great for conducting heat and electricity. That's why it's in all of your wires. And Both of these are actually very malleable, so they can be hammered into sheets very easy without breaking them. If you need proof, go to your house and look at the roll of tinfoil. That is all aluminum, and it is in one long sheet. So take a look at this table here, and you see that they have the substance here on the left, the state, so remember there are 3 states, gas, liquid, and solid. The color, another physical property, when it will melt and when it will boil. So let's take you down here to water. Usually that's in a liquid. If you need proof, look at the ocean, for example, or a lake. It's colorless, that's why you can see through it if you had it in your glass. The melting point, meaning when does it go from, say, snow to liquid water, is 0 degrees Celsius, so another important point of this table. And when does it boil for when you're making pasta? It boils at 100 degrees Celsius, also known as 212 degrees Fahrenheit. You can take a look at the other physical properties of some of the other substances given. So whenever you are identifying a substance, you have the physical properties that the chemist can use. So if you found something that boils at 100 degrees Celsius and will melt at 0 degrees Celsius, most likely you're looking at water. Whereas something else that boils at a much higher or a much lower temperature at 78 degrees Celsius and melts at 117 negative degrees Celsius, it's definitely not water. We know this because we know that water is going to only melt once it reaches 0 degrees Celsius. Therefore, we can probably make a good guess that it is ethanol, which is kind of like rubbing alcohol. So you can take this example here as a great idea as some of the physical properties. Why do we use glass for windows? Well, I think windows are used for looking outside, and you want to be able to see through them. So you want to make sure that glass is transparent because you want to still be able to see those beautiful trees outside, but not have, say, the wind and the rain come through them. So they're very resistant to heat, and it prevents the transfer from heat coming inside to outside or vice versa. That allows you to make your house as warm and cozy as you want, or calm, cool, and collected as you desire. So if you compile a list of properties for a substance, you don't have necessarily a way to measure volume. So without knowing the amount of matter in a sample, you can determine its intensive properties, meaning you can determine its color, how hard it is, those types of things, but you wouldn't know, say, how much it weighs because that's an extensive property, or how much of that matter you have. So matter can reside in a few different states. The first one is solid. It has a definite shape and volume. That just means that whenever you put your hand on the desk doesn't go around your hand in return. The solid, it doesn't usually take the shape of its container, meaning if you were to throw your computer in the trash right now, it's still going to be square like before you threw it in there. That's a lot different than that of liquid, which we'll see in a second. The particles are going to be really tightly packed together. You can see that over here. And this causes them to be in an orderly arranged fashion that prevents its ability to be compressed. So this inability to compress means that you can't squish your gigantic desk into a trash can necessarily. It won't allow you to be compressed. Additionally, you only have solids that expand a tiny, tiny bit whenever they're heated. This is very different than that of liquids and gases. The next one is liquids. So in liquids, you are going to come into close contact with one another, but they're not rigid. All right, so your liquids here, they're close enough in contact with one another, but they're not rigid or orderly, meaning you can take the water from your water bottle and pour it into another type of water bottle, and it will still be it will be in a different shape than it was before. They're not rigid. They do not have that rigidity that your desk does. So they're allowed to flow freely, and it's going to take shape of whatever container it's in. However, the volume of liquid doesn't change with the shape. So if you take a beaker full of liquid like this one and pour it into a square glass, it is not going to change the volume or how much there is, because it's just going to fill up until that liquid reaches, until all the liquid is in there. So if I were to pour this into a square beaker, the shape would look different. However, the amount in there would be the same. So the volume of a liquid is fixed, meaning it is not going to change despite where you put it. And so it has all kinds of shapes that can be in. It'll flow, and it's almost still incompressible. You can compress it a little bit and it'll expand a little when heated, but it still has that inability to be compressed. Now gases, on the other hand, you can definitely tell when there is something different there. So gas is a form of matter that is going to change its shape and its volume based on its container. The particles are usually really, really far apart, and because of that space, they're easily compressed. So if you have ever seen a scuba diver, that tank has a lot of compressed air. So whenever you're talking about gases, usually you hear two words, vapor and gas. They are very different despite being used a lot of times interchangeably. Gas is used for a substance that is supposed to be a gas at room temperature. However, vapor means something that is in a gaseous state that's usually a liquid or a solid. So for example, you may have water vapor, but oxygen gas. So what state could this substance be in if it takes the shape of its container? So since we know that liquids and gases are both able to take the shape of their container, we could assume one of those, but we're not sure after that. But we are positive that it is not a solid, for it does not take the shape of its container. Oops, sorry. So whenever you are looking at the shape of a sample during melting, it'll begin to flow, but the composition does not change. Melting is a physical change, meaning that the properties of the material are going to change, such as if it's a solid or a liquid, but what makes up that solid or liquid does not change, so you don't have to worry about that. So if you take an ice cube and let it melt in your water, you still have all water in your glass. Words that are like boil, freeze, melt, condense, all are physical changes that are reversible. Ones that are not irreversible are break, split, grind, cut, and crush. The way I remember this is you can cut your hair, but it won't come back, so it'll have to grow back. So you have to have a reversible change. So when we're talking about boiling water into water vapor, is this reversible or irreversible? Well, if you're able to catch that that vapor, it's able to be condensed back down into liquid. So here at the end are some great information on, what are they called? Vocab words. That's it. So just in case you like to have those, they're always at the end of the PowerPoint here. And I will upload this so you don't even have to write them down as I go. So hope this starts off the school year right, and I will see you soon.